All right, next example. Independent dependent variables. We have talked about the whole term bivariate means two variables. So what we've got here is we have two variables. We have distance and we have time. And what we're going to be looking at is going to be talking about which one's independent and which one's dependent. But we'll get to that. First one, draw a scatter plot using the above table. So the first one, 0, 0, easy, 10, 0.25. So on the vertical axis, each one of these is 0.1, so that would be 0.3. So 0.25 is halfway between them. So there we go. 20 at 0.38. Now, obviously, we don't have it to that accuracy, so it's just a little bit below. Next one, 0.59. So once again, even less below. Well, wasn't thus. 40, 0.82, a little bit above. If you do it too many times, it thinks you're right-clicking. That's why it keeps coming up with that. And 50, it is 1. So that it is 1. So it's right on that spot there. So there we go. That's a really nice, strong, positive, linear relationship. So I used all three of those terms. It's a linear. It's obviously positive because it's going up, and it's strong because I could draw a line almost through all of those dots. So there you go. The table below shows the time. So what are we looking at? We're looking at distance travelled over time, or in this case, time is on our vertical axis. Now, I did mention in class, I would normally have time as a horizontal axis, but it doesn't necessarily have to be. Okay, so in this particular case, what have we got? We are looking at which one is the independent and dependent. So remember the definitions of these. The independent variable is the one that the independent variable is the input. It's the one that is not affected by the other one. So in this particular case, we're looking at this and trying to work out which one is the independent variable. For this one, in our case, the independent variable, thank you, is distance. And we put that one on the horizontal axis. Now, the reason that this one is the independent in this particular case is because we're looking at the time taken relative to. So the question is actually telling us which one is the independent. So we're getting given a distance, and we're working out how long it took to get there. So the time that it took is dependent on. So for our particular case, in this particular question, the time is the vertical axis, which is the dependent variable. So we always put the independent on the horizontal and the dependent on the vertical. It doesn't always have to be time is dependent. In fact, most of the time will be independent because time happens whether you like it or not. But in this particular case, because we're looking at the time taken relative to, so that sort of phrase gives us the idea that we're looking at the time after we've looked at the distance. The distance, we've got the distance, and then you look at the time. All right, so I hope that helps.